Good evening, everyone. Thank you for joining Mr. Ish for today's video on imaginary numbers. And you know, imaginary numbers is represented by this symbol or letter I. You know, we have real numbers, which include the rational numbers and the irrational numbers, integers, natural numbers. Those are all real numbers. And we have another subset of numbers which are called imaginary numbers. Imaginary numbers are generated when you're looking at even roots, you know, where the index of the radical is even, like a square, or to the fourth, to the sixth, to the eighth root, an even root generally, and you're doing a negative value of that. If supposedly we're doing like a square root of minus a, you know, we can bring it out as I root a. We're using a number. What if I said, let's find the square root of a minus 4? You know, that'll come out as a 2i, right? The I comes out in regards to this minus, and the 4 comes out as a 2. How about if someone said this, cube root of minus 8? It's not going to generate an imaginary number, because you can actually say cube root of minus 8 is a minus 2, because here we're talking about an odd root, right? Minus 2 times minus 2 times minus 2 gives you a minus 8. So this actually is a perfectly legitimate answer. It's a real answer. It's not an imaginary answer. This right here will lead to an imaginary answer. Another way to look at it is in terms of a parabola. If you have an upward facing parabola, you know you have no intercepts here in terms of the x-axis. There's no x-intercepts, right? But what if you have a minus discriminant? You know, the discriminant b squared minus 4ac. If you have a minus discriminant value, right, when you have a negative discriminant, you will get two imaginary solutions. Let's just use I for imaginary, I am imaginary, and you get two imaginary solutions. So this is what this is all is talking about, imaginary numbers, where you get imaginary solutions, and you can represent them in terms of I. But what is more important to focus on over here is this over here. Something to be committed to memory. Anytime you have I to the power of 1 is equal to simple I squared is equal to minus 1, I cubed is equal to minus I, and I to the fourth is equal to 1. Alright, and these right here come very handy in terms of operations. Here's an example. If someone said to calculate I to the power of 13, you know 13 doesn't follow here, but everything cycles. It cycles again and again by means of a certain trend which is developed, or a certain pattern. But you can always break everything down to 2's to this, and then you can work from there. I to the 13 is the same thing as saying I squared to the power of 6 multiplied by I. Look at it here. A to the mn rule. Law of exponent is equal to a to the mn. Remember that law of exponent? A to the power of m to the power of n is a to the mn, where the powers multiply. This right here is equal to I to the power of 12 multiplied by this last I gives you I to the power of 13. You know I squared is equal to minus 1. Minus 1 to a power of 6, an even exponent will give you a positive answer. This positive answer times I will give you a positive I. So here's your final solution. I to the 13 is equal to plain simple I. You got to remember some of these tricks over here. One of the tricks is this. If you have a minus hit by an even exponent, right, you're going to end up with getting a positive answer. But if you have a minus item in a parentheses and you're hitting it by an odd exponent, you're going to retain the minus character. And that's what we have over here. You have a minus item in the parentheses hit by an even exponent and became a positive. That's what happened. It became positive. Let's look at another quick example. And this video is going to be short because we're only talking about a brief survey of imaginary numbers, just for the means of you learning how to do some of these operations. That's the entire goal of this video. Just learn how you can do operations using imaginary numbers. We're not getting into complex numbers, which is several steps higher in terms of difficulty. Complex numbers can be pretty hard. Imaginary numbers do fall in the realm of complex numbers. What if someone gave you this as a question to do? I to the power of 99. How would you go about it? Again, use any of these. You can do I squared to the power of 48. Or should I say to the power of 49 times I. What's 49 times 2? 49 times 2 is 98. 98 plus that one will give you 99. What's I squared? It's a minus 1. Now we have a minus 1 to an odd exponent, right? 49 is odd, so it's going to retain a minus. This minus will multiply with this I we have over here, and your answer will be a minus I. You could have done this in other ways. You could have used I to the 4. Maybe I should show you an example where we would do the same question using I to the 4th. How about this? Take 99 and divide it by 4. You get 24.75. 24. Let's round that down to 24. What if I say I to the power of 4 to the power of 24? 4 times 24 gives me a 96. Right? I to the 96 times I cube. Now look, or 96 plus 3 will give you the I to the 99. But we're still trying to determine what all of this equals. What's I to the power of 4? It's a 1. See, it's equal to 1. 1 to the power of 24 is still just a 1. 1 is still just a 1. Now you're multiplying by I cube. But what's I cube? It's a minus I. Your final answer is a minus I, confirming what we got before using the other example, using 2. Let me show you how we can do the same question using I to the 3. Let's show you that. Now that's where things might get a little difficult, but we can break it down easily. Look over here, I to the 99 is the same thing as saying I cube to the power of 33. 3 times 33 gives you I to the 99. What's I cube? It's minus I. Minus I to the power of 33. It doesn't really help me too much, does it, right? I have something still in here which is not clear enough. It's only clear when in the parentheses you got either a minus 1 or a positive 1. But when you have like an I or a minus I, you're still not done. There's still more you can do. How about if we break minus I into 2 components? We say minus 1 times I into the power of 33 and we separate these out. Now we got minus 1 to the power of 33, right? And then we have I to the power of 33. What's minus 1 to the power of 33? You can retain that minus, because minus to the odd retains a minus. But what's I to the power of 33? You can break this down into I square, right? I square times 16 times I. Look, 2 times 16 is 32 plus 1 gives you 33. And there will be a lesson learned in all of this coming up very shortly. We get that original minus. I square is a minus 1. Minus 1 to the power of even, which is going to become positive, all multiplied by I. And what's our final answer going to be? Minus 1 times 1, right? Minus to an even exponent always becomes positive. Minus times positive becomes minus 1. Minus 1 times this last I gives us a minus I. And here's our answer. So what's a lesson learned in these type of questions? The lesson learned is this. Either use I square or use I to the power of 4 whenever possible, because it'll get you to your answer quicker. When you start using I to the cube, you get stuck in these extra steps, complicating your entire process. So where and whenever possible, use square and to the power of 4. I'll show you a few more examples and that'll be the end of this video. So I've given you this very important trick over here. Where and whenever possible, use I square and I4 in these type of operations, because it greatly simplifies your whole operation, because it brings the minus ones and the ones very quickly early on. Let me show you a example over here. If I said find me I to the power of 25, look, as always, either use a square or a 4. I'm going to show you both techniques using a square and a 4. If I say I square, it's I squared to the power of 12 times I, because 2 times 12 is 24 plus that 1 will give you I to the 25. But I know I square is a minus 1. I have minus 1 here to an even exponent, which is going to become a positive 1 times I. I'm going to get just a plain simple I. You see, minus 1 to the power of even will become a positive. Positive with that I will give you just a plain I. Let me show you the same question using I to the 4. I to the 4 is the same thing as square to the 6. 4 times 6 is 24 times I. 4, I to the 4 is just a 1. 1 to the power of 6 is a plain 1. Multiplied by that last I will give you the I wanted, right? Easy. So again, where and whenever possible, use I squares and I4s. If you start using I cubes, you add extra steps to the entire process. I to the power of 200. This should be an easy one. Even number. What is it going to be? I to the power of 4 to the power of 50, isn't it? 4 times 50 is 200. What's I to the 4? It's 1. 1 to the power of 50, simple, 1. Done. How about this? I to the power of 67. How can we do this? I want to use square over here. Let's do 67 divided by 2. I get 33. I square to the power of 33 times I. 2 times 33 is 66, plus this 1 over here will give you 67. I square is a minus 1. Minus 1 to an odd root will retain the minus answer. Minus 1 will hit with that I, it'll give you a minus I. That'll be your answer, minus I. I'll show you 2 more different types of examples and I'm going to end this video with that. Focus over here on this question. 2 plus 3i multiplied by minus I times minus I minus, I was saying times, it's a minus. This is just going to be opening it up using FOIL. You're going to multiply, this and that and then the inner items. What's 2 times minus I? You have a minus 2i. What's 2 times minus 3 is a minus 6. What's 3i times minus I is a minus 3i square. What's 3i times minus 3 is a minus 9i. Now all you have to do is combine the like terms, but you have to combine them after simplifying anything which is more than a power of 1 in terms of I. You got a minus 2i, you have a minus 6, but this right here is simplifiable. Remember I square? I square was equal to a minus 1. What's minus 1 times minus 3 is a plus 3, isn't it? And then minus 9i. Combine the like terms. You have minus 2i minus 9i, you get a minus 11i. And then you have a minus 6 plus 3 is a minus 3. So here's your final answer. Minus 11i minus 3, or you can say, or minus 3 minus 11i. And normally you want to write these in the form a plus minus bi, where you write the constant first and you write the imaginary number second in that form, a plus minus bi. Very quickly, this is what you need to remember. I to the power of 1 is equal to I square is equal to minus 1, I cube is equal to minus I, and I to the 4 is equal to 1. So given that framework and presenting our answers in this form, look at this question. 2 minus 3i square, right? And then 4i plus 1. We'll use a FOIL method here and start solving it out. 2 times 4i is an 8i. 2 times 1 is a plus 2. Minus 3i square times positive 4i is a minus 12i cube. And then you have a minus 3i square. You have 2 things over here which have to be simplified. And whenever the power of the imaginary number is larger than 1, you got to simplify it. So let's simplify these 2 items. You have 8i plus 2. What's I cube? I cube is a minus I, right? Wherever you have an I cube, you can substitute minus I. So you have a minus 12 times minus I. What do you get? Plus 12i. See, I cube is equal to a minus I. Minus I times minus 12 gives you a plus 12i. What's I square? I square is a minus 1. Minus 1 times minus 3 is a plus 3. Now the very last step, simplifying it. 2 plus 3 is a 5. 8i plus 12i is a 20i. And it's written in the proper format. A plus minus bi. It's a form of a conjugate, alright? A conjugate, imaginary number. So keep all of these things I've shown in this video in mind. At any time you see a question which looks something like this, I to power of some number, right? Always think of this shortcut over here. Break it down using these I squares or I fours. If you start using odd powers like I to the cube, you make your question unnecessarily more difficult. So always break those down using I squares and I fours. Then remember this part over here, something you need to commit to memory. And then remember these type of questions, they can show up. And again, this was on imaginary numbers. Imaginary numbers come from negative roots, even roots. If you have minus 9, you're going to get it 3i, right? Negative roots, square roots, even roots will generate imaginary numbers. I hope you enjoyed this quick, easy video. Feel free to like it, subscribe it, and share. Thank you. Have a nice day. Bye.